Ampere's circuital law. Let's understand Ampere's circuital law. This is an alternative way of expressing Biot-Savart's law. Consider an open surface with the boundary. Assume the boundary to be made up of number of small line elements. We consider one such element of length dl. Suppose a magnetic field B is developed due to current. We take the value of tangential component of magnetic field Bt at the element dl. Multiply Bt with the length element dl, that is Bt into dl. Note that Bt into dl equals to B dot dl. No more. As we know, B dot dl equals to Bt dot dl plus B perpendicular dot dl, where Bt is the tangential component. Here B perpendicular is the perpendicular component of B to the element dl. Hence theta equals to 90 degree and Bt dot dl equals to B perpendicular dot dl cos 90 degree. Hence B perpendicular dot dl equals to 0, which implies B dot dl equals to Bt dot dl. If all such products are added together and if the elements are very small, the sum tends to an integral. Ampere's law states that this integral is equals to mu naught times the total current passing through the surface. That is, integral B dot dl equals to mu naught I, where I is the total current passing through the surface. The integral is taken over the closed loop coinciding with the boundary C of the surface. This closed loop is called Ampere loop. The direction about which boundary is transversed in the loop integral B dot dl is directed by the right hand rule. If thumb is shown the direction of current, then direction in which finger is curled in the direction in which boundary is transversed in the loop, that is, direction of magnetic field lines. Now, magnetic field outside a long straight current carrying wire. Consider a segment of some circuit. Segment contains a wire carrying current I. Now, let's look at the cross section of this wire. The current I is directed perpendicularly outward from xy plane. The direction of I is shown by dot. Magnetic field lines due to wire is shown as the concentric circles around the wire. The direction is anti-clockwise as directed by right hand rule. Let us take an Amperean loop of radius r around the wire. Now we will calculate the magnitude of magnetic field at this loop. The magnetic field is tangential to this element, making an angle between dl and B is 0. According to Ampere's law, integral B dot dl equals to mu naught I. First solve LHS, we get integral B dot dl cross closed integral B dot dl equals to cos theta. As theta equals to 0, cos theta equals to 1. Hence, integral B dot dl cross integral B dot dl equals to B integral dl. For a closed circular loop of radius r, integral dl equals to 2 pi r. Thus, B integral dl equals to B into 2 pi r. According to Ampere's law, the Ampere's law equation will become B into 2 pi r equals to mu naught I